Hi, my name is İrem K and I'm currently studying industrial engineering at Bilkent University, and today I'm going to talk about my Physics 102 lab experiment project, the relation between the area of plates and the capacitance. For our experiment, first we have our conductive plates made from aluminum foil and cardboard. We prepared them in different areas so we can observe how changing plate size influences capacitance. Next, we have a capacitor meter, which allows us to measure the capacitance values accurately for each plate configuration. We also use wires and clips to connect the plates during the experiment. To ensure our measurements are precise, we use a caliper or a ruler to measure the exact dimensions of each plate. Finally, we have a cardboard box set up to keep the distance between the plates constant and to avoid any accidental changes, like touching, moving, or tilting the plates, which could affect the capacitance values. This helps keep our measurement consistent and reliable. Also, you can see the things that we use in the lab in here as well. During my box setup, I also taped conductor plates to the boxes because I wanted to avoid them moving, which would cause differences in capacitance. After making all the arrangements, I measured the capacitance with capacitor meter for each plate configuration. We collected for measurement using plates of different areas. Here's a summary of our results. For table 1, as the area increases from 196 centimeters square to 713 centimeters square, the measured capacitance increases from 9.2 picofarad to 55.6 picofarad. This shows a clear direct relationship between plate area and capacitance. We then divide capacitance by area to check whether the ratio stays constant. For table 2, the first two values are both 0.047, which was what we expected for all data points. However, the third and fourth values deviate, especially the last one by 0.077, indicating the presence of experimental error. The results clearly show that capacitance increases directly with plate area, which is exactly what the theory predicts. We also checked the ratio capacitance to area, and while the first two values matched each other, the remaining ones did not. This tells us the overall relationship is correct, but our measurements weren't perfectly precise. Still, the general trend was clear. Larger plate area leads to higher capacitance. However, when we compared our experimental slope to theoretical one, the difference was quite large. The calculated error rate was around 532%, indicating significant experimental inaccuracies. These errors could come from several factors, such as imperfect alignment of the plates, environmental effects, or limitations in precision of the capacitor meter and ruler. Some human error, like slight variation in plate distance, calculation mistakes, or not waiting enough for the readings to stabilize, may have also contributed. Even with these issues, the experiment successfully demonstrated the key concepts of capacitance depends directly on the area of plates. Thank you so much for listening.